Hello everyone, I am Getty Martin from Songchang University, and today I'm going to present our paper with the title Sentiment Classification in Swahili Language using Multilingual Bit. We will pass through this content. We'll start with the short introduction. We'll see the objective, method that we use, experiments, result, and finish up with the conclusion. Starting with the introduction, nowadays we know due to the evolution of internet, many people use social media platform to express their opinion, their views, their feedbacks on different service and product that they use, and also they are free to give out their feelings toward certain things in their environment and in their society. As researchers, this information can be valuable if we can extract them and do analysis using automation methods. The objective of our project is to perform binary sentiment classification on Swahili data by using multilingual bit. We have these two examples here that shows the two comments extracted from DW Kiswahili that shows the labels. We will have the positive label and also the text that will be categorized as negative. Going to the method that we use the current state-of-the-art model that has shown great achievement in many NLP tasks, and it's known as BET, bidirectional encoder representation from transformer. It is a transformer-based machine learning technique which was pre-trained on Wikipedia pages and box corpus. This model was designed to pre-train deep bidirectional from unsupervised text with a masked language modeling and next sentence prediction. And in these two objectives, the first one, which is masked language modeling, the model was given the text, then part of the words in that text was masked, and the model has to predict those masked words. And in the case of next sentence prediction, two sentences were given to the model, then the model have to determine if the next sentence that followed the first one, if it's the correct sentence to follow the previous sentence. And this characteristic of bidirectional allow the model to learn the context of a word based on all of its surrounding. Other NLP models, they learn maybe from left to right or right to left, but this BET model have the ability to learn based on all of its surrounding words. In this figure, we show the architecture of a BET model. We have two types. We have BET base, which has 12 encoder, and also we have the BET large with 24 encoders. And as we said earlier, this model is transformer based model, but transformer has two parts. It has encoder part and it has also the decoder part, but BET was pre-trained, or it used only the encoder part. So as we can see here, these blocks are represented here, inside they contain these features. And now let us look the model input, what we input in our model. Our model received the specific format of input with the maximum length of 512, and each sentence has special token. It has two special tokens, which is known as classification, and also it's used in classification tasks. And this token is found at the beginning of the sentence, and also it has separation token, which is found at the end of the sentence. BET use word-based tokenizer, which split words into subwords token, and also it has the ability to handle out of vocabulary words that are not available in vocabulary file. These tokens are later converted to embeddings, the IDs that will be fed to the model. This is the figure that shows how BET model handle the input. We have the example here of the sentence lugha ya Kiswahili. First it will tokenize, break it to tokens, and then add those two special tokens at the beginning and at the end. And here, as you can see, the ability of handling the out of vocabulary, because this word Kiswahili is not, it is not available as a full word in vocabulary file, then it will be splitted in two tokens, and now each token can be converted to IDs, and these two hash symbols implicate that this word was part of another word, so is a continuation of another word, or it's a part of the word. And now let us see the general model that was used to perform sentiment classification. This is the input part. We take the text, then we add those two special tokens, converting them to IDs. Then after being processed, we have add one layer at the top, one dense layer, and the output layer, followed by output layer that has two nodes, which will determine the text if it's either negative or positive. And now let us move to the experiment part and look the dataset that we use in our experiment. The data was obtained by using two methods. The first one was to translate emotion dataset that are available in Kaggle. So what we do is we convert the 6 emotions to positive and other as negative. In the second method, we extract some text from media platforms like Jamii Forum, Twitter, YouTube, and DW Swahili. And because we have extracted some data, those data need to be labeled. So the task of labeling was done by two native speakers of Swahili language, and each annotator has to identify the sentiment of the extracted text. Then those labeled sentences from those two annotators were compared, and those with different labels, they have to agree on one label, and if it has any doubt, then we agree that we will remove them. So only those with no doubt, we take them and agree the label, then we add them together with those emotional data set and use them in our experiment. And here we show the data analysis. Total number of texts were 8.2 thousand, and among them positive were 2.7 and negative texts were 5.5, and those which we extract from different social medias were 4.9, and also we show the distribution or the ratio of the extracted data. After cleaning the text, then we split the data in two sets, 10% for testing and 90% we use for training. As we know, in social media, people are free to use any language, sometimes abbreviation and short words. So these can affect the model performance, and one of the essential process that can contribute to the model performance is to clean the data. So we do pre-processing by removing usernames, links and punctuation, and these two are examples of the sentence that we extract from social media, and as we can see, they contain many unwanted characters that have to be removed in order to increase the performance of the model. Now let us see the hyperparameters that we use to fine-tune our model. We choose the sequence length of 64, batch size of 16, and we use Adam optimizer with a learning rate of 5 exponent minus 5 and an epsilon parameter of 1 exponent minus 8. In the result, our model achieved an accuracy of 87.59, and we show the other accuracy scores like F1 score, recall and precision. As we can see here, the performance of negative label is good compared to positive. Even in the confusion matrix here, we can see the predicted label for negative in actual positive data is high compared to those negative that were predicted as positive, and this is because of the data ratio. So our data ratio was imbalanced between two labels, and this made the model to be sensitive on predicting the negative compared to the positive. And now let us finish with the conclusion. We have seen the result, and since this is an ongoing project, we expect later to take into consideration the unbalanced data ratio and also to perform comparison of other NLP models. Thank you for listening, and that is the end of our presentation.